Hi everyone, we are from group 6. Okay, the experiment we conducted is to study the time taken for the salt to dissolve in a given amount of water without any physical agitation such as stirring. Okay, so in this experiment we studied two factors. The first factor we studied temperature of water. Okay, for this factor we choose four temperatures which are 5 degrees Celsius, 27 degrees Celsius, 60 degrees Celsius and 100 degrees Celsius. For this part we kept the surface area of the salt constant. So we choose coarse salt to study the temperature of water, and the volume of water we choose is 400 ml. Okay, the second part we conduct surface area of salt. We choose two types of salt which are fine and coarse salt, and we choose two temperatures to study this factor. We choose 27 degrees Celsius and 60 degrees Celsius to find out the relationship between the surface area of the salt and the time taken for the salt to dissolve in the water.
For the first experiment, we studied the factor of temperature that affect the time taken for the salt to dissolve in water. So basically, we choose four different temperatures, uh, which is 5, 27, 60 and 100 degrees Celsius. We repeated the experiment 4 times, and we get 4 different values for each temperature to get the average and accurate results. So these are the tabulated results that we obtained. So basically, the objective of experiment A is to investigate the relationship between time taken for salt to dissolve in water at different water temperatures. As we can see from the tables, the time taken becomes shorter when we increase the temperature. It is because when the temperature increases, the particles of the solid will move faster, which increases the chances that they will interact with more solvent particles. This phenomena will increasing the rate of the salt dissolve at which solution occurs. So next is box and whisker plot for our results. So basically, theoretically, box and whisker plot should give the similarity between each group. However, when we plot our results in box and whisker plot, it shows a different data representation where there is a huge dissimilarity between each group. For example, for 5 degrees Celsius, the time taken in the graph shows 20,000, but 100 degrees Celsius shows 0 second. So it shows a big difference from each temperature. This may caused by the considerable discrepancies of the water temperature.
So now I will explain about the part B. So in part B, we choose to study the factor of surface area. The surface area we choose are fine salt and coarse salt, and the temperature is and we kept the temperature at a constant level. So for this part, we studied two temperatures. First, we keep the temperature constant at 27 degrees Celsius, and we find out the effect of fine salt and coarse salt at this temperature. So the value we obtain for each trial is shown as below. The average value, which is the average time taken for fine salt at 27 degrees Celsius, is 605.65 seconds. And for coarse salt, the average time taken is 3525 seconds. Then we repeat the experiment with 60 degrees Celsius by keeping the temperature at 60 constant at 60 degrees Celsius. So the values are given as shown in the table here. For fine salt, the average value is 104.34 seconds, and for coarse salt, it's 375.11 seconds. Then we plot the graph for 27 degrees Celsius only. So this is the graph for 27 degrees Celsius. The blue line shows find data for trial, data of each trial for fine sol, and the red line shows for coarse sol. So when we see from the graph, it's clearly shown that at 27 degrees Celsius, the fine sol recorded lower temperature compared to coarse sol. This is because of the reduced surface area of fine sol, which means it has a greater contact with water molecule, which increase the rate of reaction and decrease the time taken for the salt to dissolve. Furthermore, we also can see clearly in the graph that the data for each trial for fine salt is within the population, which means the value of each trial doesn't deviate much from others from one trial to another. But for coarse population, it's not same. The data is quite inconsistent and it's not within the population. For example, we can see that there is much difference between the first trial and second trial. So it's not within the population and the data deviate much compared to fine sol. Now I will explain about the interaction plot. For interaction plot, we studied two-way interaction. Okay. We choose two temperatures which are 27 degrees Celsius and 60 degrees Celsius, and we experimented it with two types of salt, fine salt and coarse salt. So this is two-way interaction whereby we want to study the two factors together and which factor is dominant and how one factor influences the other factor. So this is the bar chart and this is the graph to study the relationship between temperature and surface area together. So when we see the blue line stands for fine salt and the orange line stands for coarse salt. So at 60 degrees Celsius, both fine salt and coarse salt recorded very low time taken, which means it reacts very fast. Okay, at 27 degrees Celsius, the fine salt recorded low temperature, but the coarse salt recorded very high time taken. Sorry, at 27 degrees Celsius, the fine salt recorded very low time taken, while the coarse salt recorded high time taken compared to the fine salt. So the main effects in these experiments are temperature, which are 27 degrees Celsius and 60 degrees Celsius. And one more main effect is surface area of salt, which is coarse and fine salt. And there is an interaction between the surface area and temperature. These main effects were qualified by an interaction between the surface area and temperature. Each main effect depends on the level of the second independent variable. The high temperature, which is 60 degrees Celsius, increase the reaction rate for both fine salt and also coarse salt to dissolve by decreasing the time taken for the salt to dissolve. While at 60 degrees Celsius, the coarse salt recorded high temperature compared to the 27 degrees Celsius.
For analysis of variance of experiment A, we the null hypothesis is that all the means of all the groups is the same. So we tested this by constructing an ANOVA table with an alpha value or significant value of 0.05. Here we can see that F value is smaller than F critical, and also P value, which is 0.095, is also larger than 0.05, meaning our null hypothesis is accepted because our data is within populations. But for our bars and whiskers graph, you can see here it is not related to each other. This is because of our large difference of temperature which we conducted experiment, which is 5, 27 and until 100. For part B, we conducted the experiment at 27 degrees Celsius by using a different type of salt, which is fine and coarse. So the ANOVA table is here. F is smaller than F critical, and P value is larger than alpha value, which is 0.05. That also means that our data is within populations. So for part B, we conducted by using the same method but at different temperature. So here is our ANOVA table. F is much smaller than F critical, and our P value is larger than alpha value, meaning our that data is within the populations, and our null hypothesis is also accepted.
That's all from our group. Thanks for your attention. Thank you.